All right, good afternoon, everybody. My name is Liam England. This summer I worked with Ian MacDougall on the Research Technology Infrastructure team, and my project was bridging Alaskan energy data gaps. So this is a brief outline of my presentation. I'm going to talk about my project and what the goals of it were, what did I end up doing, what I took away from it, why my project matters in the scope of ACEP's work and Alaska as a whole, and the conclusion, what I learned, and personally what I'm going to take away from this summer. So the bottom line of what I did is I developed a comprehensive geospatial data set of electric utilities in Alaska and their service areas, transforming scattered data into a unified resource to enhance public access and usability. And I'll explain what that means because that's a little high level. So basically in Alaska, electric utilities are regulated by the Regulatory Commission of Alaska, and the RCA approves the boundaries that each utility is allowed to operate within. That boundary is known as a service area. And so on the RCA's website, you can go to each utility's webpage and look at what their service area is, but you can't see all the service areas in one map or in one data set. So my project aimed to kind of bridge this data gap by creating a data set that had all the service areas merged together, because without that, it's kind of difficult to see which parts of Alaska are served by a regulated electric utility. At least in map format, you could look at it kind of like in a list, but the idea is that to bring this data into a map format. So my project aimed to address this gap. And so this kind of just sets out the goals in a more formal way, was to unify this fragmented data and address those barriers to access, and to create a publicly accessible geospatial data set that maps all those electric utilities and their service areas. And because there are so many utilities in Alaska, that kind of heightened the need for this. There's a lot of microgrids. I think there's either 120, 130, something around that. So there's definitely a need for a unified data set like this, instead of having to download and individually work through like 100 separate files. That's very tedious. Here you can see a map of the data set that I created. So this shows all the service areas of electric utilities in Alaska. You can probably recognize this. That's GVA and the rail belt, and then you can see all the little microgrids around Alaska. To me, it's an interesting map because you can see the vast majority of the state is not served by a certified electric utility, but it doesn't mean that nobody lives there or that the people that live there don't use electricity, but that people who live there probably rely on individual generators for their property, and they're not on a grid system, or if they are, that grid system isn't regulated. And there's also an interactive version of that map that I created that you'll be able to access at the end of the presentation. So the bigger picture of why my work matters and why this data set matters is that it can be used to improve and simplify access to energy data in Alaska. And I worked with my mentor to integrate this data set into the Alaska Energy Data Gateway. And for those of you who don't know, the Alaska Energy Data Gateway is a site that provides access to Alaskan Energy Data Gateway on the state and broken down at the community level. And so ACEP is working on launching a new version of the Alaska Energy Data Gateway, and I've been working with my mentor to kind of add this data set to the site to kind of enhance it. It's a small part, but an important element, in my opinion, of ensuring that the Alaska Energy Data Gateway can empower researchers, legislators, the public, anyone who can use this site with improved access to this information. They can have a better understanding of Alaska's unique energy landscape. This is kind of a conceptual mock-up of how it might look. The background, that's how the community summary page of the Alaska Energy Data Gateway looks right now. There's not actually a map on it right now, but that's how I envision it might look when the integration is done. So you can see this is the community summary page for McGrath, and McGrath's utility is McGrath Light and Power. So that's a pretty simple scenario. It's just a microgrid that only serves McGrath. But on the other end of the spectrum, you would have more complicated utilities like GVEA, which is not only serves multiple communities, but is on the rail belt grid. So I think being able to visually see the service area in a map format is pretty informative and helpful for people to be able to visualize, how their electricity and how electricity in Alaska, works. And it's exciting and gratifying, definitely, to see a direct result and benefit of my work this summer. So the methods, what I did to get this data set, there was data collection. All the individual files on the Regulatory Commission of Alaska website were downloaded with web scraping, and then there was some data cleaning, which I'll talk more about on the next slide, and then some data processing and merging, which was just taking all the individual files and kind of combining them together into one layer. Another part of what I did was publishing the data onto a GitHub repository and creating a website and a map using Quarto and Leaflet, which are some coding libraries, and then integrating the data set into the Alaska Energy Data Gateway, which I kind of touched on already. Some of the lessons learned, definitely the biggest challenge and something that whoever continues working on this will have to deal with is the data quality issues. Sometimes the service area map that was on the Regulatory Commission of Alaska's website wasn't actually the current version of the service area. Although utilities don't change very fast, sometimes they can acquire another utility, or they can just change in ways that would mean that the service area can expand or shrink or things like that. But the service area map on the website wouldn't actually be the current version. It might be the service area how it looked like 10 years ago. So that would be an issue that I had to figure out how to address that. And there wasn't really a universal fix. I couldn't just click a button and say, make all of them up to date, because my project wasn't about mapping them myself. It was about, taking this existing data and kind of transforming it into this new resource. So what I ended up doing is, adding metadata to the data set to say, these service areas are up to date, these are out of date, and this is the date that they represent, so that whoever uses the data set can understand kind of the issues the data quality issues that are within the data set, and they can deal with that when they use the data. Which is kind of why metadata and documentation is very important, which is one of the main things I took away from this project. But even with that, it doesn't have to be perfect, because the status quo, I guess, beforehand is that all the service areas are individual. And so even with the data quality issues coming in and having them all merged, having a data set, even with these issues, is we're in a much better place than before, even with the issues. So the conclusion, I developed a structured data pipeline and published this geospatial data set of service areas. I look forward to seeing what others are able to accomplish using this data set, starting with the Alaskan Energy Data Gateway. My favorite parts of this project were, there were a lot of favorite parts. Being able to work on something meaningful that addressed a need, the problem solving that was involved. It was an invaluable hands-on experience with GIS and computer science, which are two areas that I'm really immersed in. Being able to learn about Alaska and its energy landscape was a really great opportunity. My least favorite part, the data quality issues were annoying and tedious, but the problem solving aspect, it was rewarding to work through those problems in the cases when it was possible. The ones that couldn't be solved were more annoying, but that's how it goes. And here's the QR code if you want to play with an interactive version of that map. It works better on computers though, but maybe it'll work better on phones in the future. But that's it.
Liam, I have a question. This is Annalise. Can you talk a little bit about what we're, yes, I'm coming from the ceiling. Can you talk about the student extension that we're working on with REAP?
It was at the end of the question.
Yes, just share a little bit about the student aspect, because I think it's really cool.
Yeah. So for the T3 aspect of this internship, I'm working on a worksheet that high school students will be using the Alaska Energy Data Gateway to answer questions about energy in Alaska. So there'll be the beginning of the assignment will be they'll kind of answer some questions about their current understanding of how energy in their community works, and then they'll use the Alaska Energy Data Gateway to look at the community summary page for their community, like one other community, and they'll write some answers based on the different information on that community summary page, which is like, the rates, the energy rates, like the sources of energy production and capacity and things like that. And then they'll do some sort of reflection where they'll say like, why is energy in this community different in this community, and like why might it be different and things like that. And so I think that's a really interesting, there's definitely interesting potential for education, not just for, people who are going to use this casually just to look up information that they want to know, but in a more like educational, formal setting. So I'm excited about that.
I had a question. With the data that you found, what was your main source of like finding data for specific like rates or generation capacity, all that sort of stuff? And what's the method by which the site would be able to be updated if things change with those numbers?
Okay, so first part, I'm not the main person developing the Alaska Energy Data Gateway. It's a big team on that. But so I don't know if I can provide a good answer on that, because the rates and stuff, that's from other places. The only data that I really worked with was the kind of these. Oh, I'm not moving the slide, but you know, the map that I showed you with the service area outlines. I didn't really pull in all the other stuff. I mean, you can see that on the Alaska Energy Data Gateway, but it's not really like linked in my data set.
I guess I could ask a question related to map then, if that's a better question.
Well, I mean, yeah, if you want to.
Well, I was kind of curious, how are you handling communities that are interconnected versus communities that are islanded on the map? Like, is there a specific way that because in the map that you showed us, it was all just colored in the same. So for example, like, do you have visions of like a way that they would be portrayed differently, or do you think that doesn't matter as much on the scale? It's just you want to see which influence where.
I mean, that was just a pretty simple map with everything in orange. So I definitely think like you said, there's a better way to symbolize that, to show the different ones. I think what you're kind of getting at is that there are some utilities that have service areas that are not connected. Like there's the Alaska Village Electric Cooperative, which serves like, I don't even know how many, like 50 or something different remote communities, and none of them are connected, but it's all one service area. It's just like 50 different areas all over the state that are. So technically, if you click on one, you're getting a service area that's, you know, a bunch of different kind of like checkerboarded area across the state. So I think to break it down by community is kind of an additional kind of variable on top of the equation. But the way it's kind of represented, it's like by corporate entity or by utility, I guess, because I think that there's only one entity that's kind of licensed or has the certificate, and then they don't have to get a new one for like each new area that they serve, which does make it more complicated on like a map level. And then your second question about, I forgot it. So well, no, I don't know. I think I might have a follow-up to it, but let's say those service areas change in the future, which they probably will. Yeah. How does this application allow for updating? Yeah, so how it works, and I kind of glossed over it pretty fast, but the RCA website, there's a search that you can do for the current active electric utility. So the script kind of scrapes the results of that search and puts it into a CSV or into a data frame in R. And then for each of those utilities, it goes to that page and downloads the service area file that RCA publishes, and then it assembles them all into a data frame. So theoretically, if there was a new one added, and if RCA published a new service area file, then the new data would be reflected. But the kind of the issue is that RCA has been slow to add new service areas. So I think there's been like a couple new utilities added in like the last 5 or 6 years, and there's no service areas file like maps for those on the RCA website, which means they're not represented in this data set really. So it kind of just depends on them, since they're the upstream, and since it was kind of out of scope for this project for me to just like open up a mapping program and start drawing maps of stuff. Like the idea is that it's taking their data and doing something cool with it. And I think that's kind of what Mateo's question was. It was like, how do you know they're going to update it or something like that? So like that, we don't. that's kind of why I had to add this metadata to say, you know, this is outdated, because originally I didn't know the scope of the outdatedness, I guess. So I had to write some code to compare like the date in the map to the date that the utility was last updated. So if it said on the website that, you know, the service area was expanded in 2020, but the map said 2015 in the corner, then I would like say this one's outdated. And so I was able to incorporate that in the script.
This may be beyond the scope of your project, but do you know if there are plans to make the updates on the maps automatic, or will it continue to be like a manual process?
That is a good question. I think that is something I have discussed with with Ian. Because the updates are pretty slow, like, I mean, the last new utility that I think was certified was in like 2020 or 2022 or something like that. So it probably wouldn't be like an everyday thing that this would run automatically, but I think the idea is that maybe we could set it up to run like every 6 months automatically or something like that, because the package or the code is set up that it can kind of, you just like press one button and it will do all the steps in order. And I did kind of set it up envisioning that it could run automatically, but luckily the data is kind of very slow changing, which is kind of because of the nature of utilities and also because of the nature of RCA updating things slowly. So definitely there is potential to automatically update it, but it's not very urgent, I guess.
Chandler has a question.
Hi, Liam. This is Chandler. Thanks for the presentation. I was curious if you've had any sort of conversation or relationship with people at RCA, and kind of a follow-up question to that is, it's really neat to hear that you set up the code so that it can be somewhat automatic and updating. And I'm curious how dependent that is on the current structure of the RCA website, and if that's updated, if there's like a channel of communication that exists to be able to update ACEP side as well.
Yeah, both of those are good questions. Currently, no, but that is an aspect that Ian and I have discussed. I think that somebody at ACEP has worked well with RCA on a couple projects before. I forget who. I'm sorry to that person. But the idea is that, you know, there are some issues that I've identified in their data, like a certificate, where a certificate is like a certificate for a utility to operate from like 1970 that should be marked inactive, but it wasn't, or like a few other small things like that I could just email them and say, hey, you forgot to do this. But so definitely there's a potential for some collaboration to be able to improve and for both parties to benefit, definitely. And it's definitely, since it's more of a cycle, I guess. It's not just, you know, their data is from here and it goes down, and now we have this data. It's definitely, you know, we can contribute back to them and let them know what we found, and that can help whoever uses their data directly from them will also benefit. And so it's to the benefit of everybody, I guess. And the second question about the website, yes, it's pretty dependent on how their website currently operates, because there's a lot of like hard coded, like you know, the link will be in this paragraph that's like has this certain ID or whatever. But their website has been pretty constant for a while, what I have heard and from what I've checked. So that will be a concern whenever they change the back end of their website. The package or the library code won't work anymore. But I would say that's also not a super urgent thing, because I would not